If a magnetar appeared where the moon sits, every credit card, hard drive, and electronic device on Earth would be erased in an instant. Our digital world, gone, without warning or explanation. At just 100 miles, the force grows unstoppable. The atoms in your body would stretch apart, torn into spaghetti-like strands by a magnetic field that shreds matter itself. This devastation would unfold long before the magnetar touched our world. Get closer, and the threat becomes personal. At 600 miles, a magnetar's field would reach into your body, pulling the iron from your blood and twisting your molecules. Your body would become a living compass, helplessly drawn toward this stellar monster. What if a dead star could rip the iron from your blood from hundreds of miles away? Imagine a force 1 trillion times stronger than Earth's magnetic field, lurking unseen in space. This is not science fiction. This is the reality of magnetars, the most magnetic objects in the universe. A rogue magnetar is more than a threat to technology or life. It is an existential danger, able to erase our world silently and invisibly before we could even react. How do you create something so magnetic it defies the rules of physics? The answer begins with the violent death of a massive star. Yet magnetars are not just cosmic destroyers. They test the boundaries of what we can understand. To grasp their true nature, we must explore their origins. When a star at least 10 to 25 times the mass of our sun runs out of fuel, it does not quietly fade away. It explodes in a supernova, unleashing energies beyond anything humanity has witnessed. In the chaos, the star's core collapses, compressing a mountain's weight into a sphere no larger than a city. The result is a magnetar. Its magnetic field is millions of times stronger than any magnet ever built or imagined. Place one halfway to the moon, and it would erase every digital record on Earth. These cosmic beasts can send shockwaves across galaxies. They are not just threats. They force us to confront the very meaning of matter and physics, stretching human understanding to its edge. This creates a neutron star. But to become a magnetar, even more extreme conditions are needed. The collapsing core must spin rapidly and already possess a fierce magnetic field. As the star contracts, these forces amplify magnetism trillions of times, pushing the limits of possibility. Magnetars are no myth. One proved just how real and dangerous they are. The gamma-ray burst ionized Earth's upper atmosphere. Radio signals vanished. Satellites blinked out. Worldwide sensors went haywire, all from a blast that began before humanity existed. Magnetars exist, and their reach is astonishing. Our technology, our atmosphere, even the routine of daily life can be shaken by an event halfway across the galaxy. On December 27, 2004, a magnetar called SGR 1806-20 erupted. It was 50,000 light-years away, yet in 1/10 of a second, it released more energy than our sun will emit in the next 150,000 years. For a moment, some scientists wondered if this was an alien attack. The energy was so strange. But the truth was stranger still. The universe itself had fired a warning shot across the cosmos. If a magnetar can affect Earth from such distance, what if one entered our solar system? But what is a magnetar, and how does it become so dangerous? To answer, we must witness its violent birth. Imagine a cosmic missile, thousands of times stronger than any bomb. Aimed at us, how would the world end? Magnetars are not stationary. They can be flung from stellar explosions, careening through space at millions of miles per hour. If one entered our solar system, disaster would begin before it even arrived. The first blow is not magnetism, but high-energy radiation. These waves could strip our atmosphere, boil the oceans, and trigger mass extinction. Life would start vanishing while the magnetar was still light years away. Closer, at 1,000 miles, its magnetic field would wrench every metal object skyward. Cars would rise from the ground, steel beams would twist, and gravity would seem to fail. Physical laws would appear to break before your eyes. At 600 miles, the threat turns personal. The iron in your blood would pull toward the magnetar, your body straining under forces evolution never prepared for. Birds and whales would lose all sense of direction. But why do magnetars exist, and could we detect one before it is too late? To answer, we must look at their cosmic origins and rarity. You are more likely to win the lottery 100 times in a row than encounter a rogue magnetar. At 100 miles, reality unravels. Magnetism distorts atoms into spaghetti shapes, chemistry fails, and matter falls apart. Even light bends, the world's colors warp, shapes blur, and existence itself betrays you. What is lost is not just life, but memory, meaning, and the fabric of reality. Their active lives are brief. Each magnetar remains dangerously active for only 10,000 years, a cosmic blink. On the scale of stars, that is less than a heartbeat. Consider this, across our galaxy, which has nearly 100 billion stars, astronomers have discovered only about 30 active magnetars. These are unimaginably rare, like winning the universe's ultimate jackpot. So, what should you take from this journey to the edge of cosmic possibility? Now consider the immensity of space. Even if a magnetar were to wander, the distances between stars are so vast that the chance of one threatening Earth is virtually zero. The universe is mostly endless, silent darkness, not a shooting gallery. That is the real victory, not just safety, but how we face the unknown. Do we shrink from unimaginable danger, or marvel at our power to comprehend nature's wildest extremes? But here is what matters. Our ability to find, study, and understand these distant monsters is a triumph of curiosity. Through telescopes, satellites, and brilliant minds, we have captured signals from these strange objects and unlocked their secrets, transforming terror into knowledge. Let us reflect on what magnetars reveal about both the resilience and the vulnerability of life in our universe. The next chapter explores just how close we have come to such cosmic peril. The universe teems with monsters, but our true wonder is this: we can name them, study them, and reveal their secrets. A magnetar's power could shred atoms and erase every memory ever stored. Yet we can measure their fields, trace their violent births, and predict their effects. That is a triumph of science, a refusal to simply fear the dark. Turning terror into wonder is our superpower. Our awe is not just fear, but reverence for the mind's reach. Each discovery expands imagination, pushing back the darkness. After all we have faced, every cosmic terror and impossible force, comes a paradox. The more frightening the universe, the more profound our achievement in understanding it. Magnetars are not just distant threats, they are proof of human curiosity and our relentless urge to unravel the universe's most extreme mysteries. But the stakes are real. Surrender to fear, and we lose curiosity. Lose awe, and we risk forgetting the fragile, hard-won beauty of our world. Balancing danger and discovery keeps our wonder alive. So next time you hear of a cosmic monster, remember, it marks both the peril in the void and the measure of our progress.